Hanspeter and Jovana study the warming of different land uses and its effects on soil in our climate. The scientists Hanspeter and Jovana measure which surface is the hottest on a sunny day. Is it the bare agricultural soil or the paved road next to it? Hanspeter asks various people.
Welches von denen ist der heißeste?
I would say asphalt, tarmac, road. That is much higher just from the black color. I would be completely wrong, but I would say at least 40 degrees. The asphalt road is the hottest. It gets about 50 degrees.
Which one is the hottest? Tarmac. Are you very sure?
100%.
Are you 100% sure?
1,000%.
1,000%? Do you know that you are all wrong? All wrong.
The thermal camera left shows the surprising difference. The road emits less heat than the bare, dried-out soil in the farmland next to it.
The explanation is simple. The asphalt is compact. The sun shines on the asphalt conducts this heat, which is generated on the surface, conducts it into the ground. But the soil has air. It has pores in the soil. It is a very good insulator. This means that the heat that develops on the surface can only penetrate slowly into the soil. It builds up. The surface gets brutally hot, 5 to 10 degrees hotter than asphalt.
What do hot temperatures, no land cover, and intensive tillage mean for the soil? Hanspeter compares the soils in an experiment. Pieces of soils protected with a plant cover are on the left. Tilled, bare soil is on the right. Then they are put into water. The soil on the left remains stable. Microorganisms and plant roots build a strong structure, a key to healthy soil. The right soil falls apart more and more. Hot, dry, and bare soil makes it hard for soil organisms to survive, affecting soil stability and overall soil health.
When the stability of the aggregates is good, the soil can perform its function. Water penetrates into the soil, fills it up and goes into the groundwater. If not, if these aggregates fall apart, it fills up all the gaps in the soil. The water can no longer infiltrate, it has to flow away on the surface. It causes major damage further down, even major floods, all connected with the stability, with the health of these top 5 centimeters.
Here the impacts become clear. The water floods across the fields and causes erosion because it cannot infiltrate into the soil. Valuable soil gets lost in the sewer, causes pollution and damage downstream. After the rain, the soil is compacted with little water available for plants. This can be shown with a rainfall simulation. Under rain, the uncovered soil seals, and the water runs off on the surface. The upper cylinders show the differences in runoff and erosion. The bare soil on the left shows high runoff and erosion. It is also the soil with weaker aggregates. The covered soil on the right has little runoff. The cylinders below collect the water stored in the soil. Little on the left with bare soil, much on the right with covered, no-till soil. But how can we avoid exposed soil in the summer? such that the soil always remains covered, productive, and cool? These farmers share their experiences. If we look here, inside this mulch, there is only a path in between. I don't assume that the soil condition is different. At 1 to 2 centimeters, we already have moist soil. It is not dried out, and moisture still comes up from below. Our idea is simply to follow directly behind the harvester. There we place a grain at 5 centimeter depth, where it is still a little moist. The challenge is that it grows. Then we wait for the rain so that it develops. The water balance is undisputed. The less tillage, the better it is for conserving water, and we have more water in the soil. This means more water for plant production. Through the summer and into autumn, a dense green manure grows. This is then rolled and immediately resown without further weed control. The difference is considerable. This dusty, dry, hot soil in the summer regenerates with difficulty. Green plants, on the other hand, protect the soil from heat. The plants use the sun's energy for their growth and evaporate water in the process. This cools the surroundings. Together with researchers, advantages and disadvantages can be demonstrated. Bare soils heat up strongly. Tillage exposes cool subsoil to heat. Green areas, on the other hand, cool down. Heat and intensive tillage damage the soil aggregates. Cover and stable soil aggregates protect during heavy rainfall and help to store more water for dry periods. There are solutions. The key is to keep soil covered as much as possible. A green cover, especially in the summer after harvest. Farmers and researchers continue to look for improved practices, adapted to farmers and to a changing environment. Green cover, cool for our environment, our climate, and for us.